Hey guys, what's up? My name is Gabe and this is Games with Gabe, and this is the next episode in the Coding a 2D Game Engine in Java series. If you remember in the last episode, we left off here where we basically have a little scene and Mario can run around, jump on enemies, kill the enemies, and all that good stuff. In this episode, what I want to do is get the pipes into place so that we can lay down different pipes and we can enter through one pipe and then we'll exit through a different pipe. So in order to do that, we're going to have to come up with a little bit of a system that will make this easy on ourselves. So let's take a look at some drawings to see how we can create a system that will make this work with the engine we have. All right, so imagine for a minute that this is Mario and this is a Mario world, and these pipes are actually Mario pipes, not the bad drawing that I have here. So if we want to connect these two pipes together, think about how we could do that with the engine we have. Right now, there's no real good way to reference game objects, but we do have one function, which is getGameObjectByName. So if we give this pipe a name, say pipe 01, and then we give this a pipe another unique name, say pipe 02, we could connect these two pipes through a reference obtained at runtime, right? We could basically say, okay, I want this pipe to grab a hold of this pipe at runtime, and they are connected to each other. Now, that's the pretty easy part, but then how do we determine where to place Mario? If Mario jumps up onto this pipe right here, first of all, how can we tell when he presses down? Well, we can tell when he presses down just by checking for which key, but let's change this up a bit. Say there's another pipe, because this does happen in Mario, that looks more like this, and we want Mario to go through when you press the right arrow key. Well, now we need a way to determine which direction the pipes are facing, and we also need a way to determine which side of the pipe Mario is on. We already know we can tell which side of the pipe Mario is on pretty easily. I'm going to erase this real quickly. If Mario is on top of this pipe, we know that the physics engine will tell us that there's a collision happening between these two objects. In which direction the collision is going to be facing will depend on the object. So if we're looking from the pipe's perspective, we're going to be getting a collision pointing downwards because that's the direction that Mario is trying to push the pipe. But if we're looking at Mario's perspective, we're going to be getting a collision going upwards because that's the pipe that Mario is trying to sit on the pipe. So we can simply check for the collision normal and see which direction is the highest. Now we have to be careful because Mario could hit the pipe at a direction. If he's running to the left, say, and he presses up, then we could get a slight vertical velocity. And so even though there's a slight vertical, we know that this is actually a horizontal hit because you can see from the direction that it has more horizontal velocity than vertical. And this is why we always make sure that we have a threshold value when we're doing our box 2D normals, because box 2D could give us something that looks slightly like this. Clearly that is a normal that we would want to count, but we just have to make sure that it is above a certain threshold. And so if you accept anything a little bit too low, say something like this, that might not actually be true because he could just be sliding over the edge of the pipe. So using the same concept, if Mario is running into this pipe, he'll have a normal hitting out this way. And from the pipe's perspective, Mario will be running into it. So we can check the normal to determine which direction Mario is facing. And then once we do that, we can figure out, well, if it's left, then when Mario presses the right arrow key, or D, if we're using WASD, enter the pipe. Then to make Mario enter the pipe, we simply move his transform from here through the pipe here. And then what we can do is we can just use the pipe's position plus a certain value. If the pipe exits on the bottom, then we move Mario down. If it's on the top, then we move Mario up here, right, left, so on, so forth. So we simply need to come up with a mechanism to give pipes directions, which I represent using an enum, which I think I called direction or something or other. And this direction enum just has 4 values: up, down, left, and right. So we can have pipes facing up, down, left, or right, and we can encode those through specific prefabs that we generate inside of our prefab class. And that is most likely the direction we will take with this, no pun intended. So let's jump into the code and see how this works. All right, so I am back inside of our level editor scene, and we have a certain sprite sheet here called pipes, and you'll notice that its size is 32 by 32, which means that it's twice as big as the normal sprites, which are usually 16 by 16. So we can just use these to create some special game objects inside of our prefab section. So we have the decoration blocks, and I'm going to scroll down to where we have our prefab selector inside of the level editor scene initializer. And if we scroll down, I'm just going to place these after our last item here, which I believe was the Goomba. So we'll just add in another few lines of code here. We'll say sprite sheet pipes equals asset pool dot get sprite sheet assets slash images slash pipes dot png. And then we can literally just copy this because we're going to be doing pretty much exactly the same thing here again. Once again, you should probably extract this out into its own function since we do the same thing so many times. The only difference is we're going to be getting sprite 0 and we're going to be getting it from the pipes sprite sheet, not the player sprite sheet. Then we'll get the texture ID. We will get push a unique ID. We will get the texture coordinates and we'll simply do the same things here. And then lastly, we're going to say generate pipe for our prefabs, and we're going to create this function in a second, and this will take in a direction dot down, which we're going to implement as well in a second. So this will basically generate a pipe with the direction down, which is the same as this picture. Let's also make sure that we don't forget to add in ImGui.SameLine here and ImGui.SameLine right here as well. And then let's go ahead and add a few more. Actually, we can just copy right up to here. And this will be for the other pipe. So we'll add 1, 2, 3 more. And this will be 0, then 1, 2, and then 3. And for 1, that is the picture of the pipe facing up. For 2, that is the picture of the pipe facing right. And for 3, that is the picture of the pipe facing to the left. So that should be all of our bases covered. And I'll remove this same line here so that we don't get any weird things when it comes to the next tab. And as for this direction class enum, let's generate that real quickly. We can just scroll down to editor and we'll go ahead and add a new Java class, then just hit enum instead, and we'll call this direction. And like I said, we can just have this tab up, down, left, and right, which should be all we need. And I put that in the wrong package. We want this inside of Jade, so just move that over if you made the same mistake as me. And then we can click on this related problem, and that should be cleared up. So we should have no errors inside of here, and we should have no errors inside the main file as well. All right, let's go into prefabs now so that we can create this generate pipe function. And I'm actually going to copy one of these smaller functions because once again, we're going to be using some very similar states in everything for this. So I'll just copy the block coin and we'll be able to simplify that a bit more. And I'll scroll all the way to the bottom. There we go. And we can take in, for the generate pipe function, we will take in a direction, and this will be the direction of the pipe. So we'll say that our sprite sheet is our pipes, and we'll say get sprite sheet pipes.png not items. And then we can create like a little helper function to get the correct index for the correct image. We'll say if the direction is equal to direction.down question mark. This is just a ternary statement. If that's true, then we'll use index 0. Otherwise, which is what the colon is, we can use direction equals direction.right. If that's true, then or actually I'll do up so that we do this in chronological order. We'll use 1. Otherwise, if direction equals direction.right, we can use 2. Lastly, otherwise, we can use if direction equals direction.left, we'll use 3. And otherwise, we'll use -1, which should throw an error. We should never get that, but just in case it somehow magically happens, we have that base covered as well, and it should throw a runtime error. We can make that a little bit safer as well, and we can say assert index does not equal -1, invalid pipe direction. And that just makes sure we have a little bit extra protection there. We know what should happen, and this will give us a little message in case that does happen. And then we'll just say that this is going to be pipes.getSpriteIndex. And we want to change the size too. So right now we have these at 0.25, but we actually want these at 0.5 since all the pipe sprite sheets are actually twice as big. So we're just going to do that to make it a little bit easier. We don't need any state machine, so I'm going to go ahead and remove all of that animation state. I'm just going to go ahead and remove all of that actually. Okay, and then let's finally call this a pipe because that is what it is, and we'll return a pipe. So what do we need? We need a rigid body first of all. So we'll call that RB equals a new rigid body. We're going to say RB.setBodyType to BodyType.static. The pipe never moves, it stays in one place the whole game, so we can do that. We'll set the fixed rotation to true. We'll set continuous collision to false. And then we'll say pipe.addComponent RB. Fixed rotation and continuous collision shouldn't really do too much. Continuous collision might be important, but it's not moving, so it doesn't really matter. We should have really initialized continuous collision to false, since that is the appropriate value for most objects. Next, we're going to use a box 2D collider to represent the pipe. So we'll say box 2D collider b2d equals a new box 2D collider. Then we'll say b2d.set half size to 0.5f 0.5f, which is going to be a new vector 2f. And that should give us the correct bounds, and we'll add that component to our pipe. Finally, we want to add in a component, which is a new pipe, and we'll give it the direction. So that's going to be sort of our pipe component. And we also want to make sure we add in a ground component. That way Mario can walk on it. Now, we don't actually have a pipe object, so let's go ahead and inside of components, we'll create a new class and call this pipe. This pipe is going to extend component. And for now, we're going to leave it empty. We may as well add the constructor. So we'll say public pipe direction, just so that we have that. And then we'll store that as a private variable, private. And this won't be transient because we do want to keep this. And then we'll just say this.direction equals direction. There we go. Now, if we go and run this, we should be able to add pipes into the game. They won't really do much, but it will allow us to at least add them. So if we hit prefabs, you can see we have the pipes. If we hit this block here, you can see I get this pipe added into the game. We will have to fix how this is added because right now it's sort of in the middle of the blocks. So we will fix that up in due time. All right, so inside of our pipe class, we'll go ahead and add some member variables that we will need. First of all, we will need a string, which is going to be our connecting pipe's name. So that will be the name of the game object we connect to. We, of course, want to serialize that because we want to save it. We also want to mark whether this is an entrance or not. This will be good because this way we can mark which pipe you go in through, and you can't go in through the exiting pipe. This is just because if you want a one-way pipe, you need to make sure to mark that. I think with this system, you could also have two-way pipes if you want to, which is cool. We also want to make a transient game object, and that will be the connecting pipe, which is set to null initially. And we will also have a transient float entrance vector tolerance, and this is basically that tolerance I was talking about. We just want to make sure we're above a certain threshold before we say that the player can enter, and that's where we set that value. And we'll have a private transient player controller colliding player. And that will just keep track of the player whenever he collides against us. Okay, inside of our start method, we will want to make sure to get a hold of that connecting pipe. So we'll say public void start, and then we'll say connecting pipe equals window.getScene.getGameObject, and we should be able to get a game object by name, but we don't actually have that yet. So let's go ahead and add that function. So if we go into getScene, and then if we go into the scene class, we can scroll down where we have our other getGameObject method, and we can create something very similar. So if we just copy this, we're basically going to want to do the same thing, except we will use a string GameObjectName. This way we can get game objects by name if we wish. And then we can just make sure that the game object's name is equal to that game object name, and make sure to use dot equals because Java does not like using the equality operator since you can't overload that. This will return the game object or null. And if we go back into here, we just need to add in the game object now by saying connecting pipe name. That should give us a reference to the actual game object. Next, we want to do the update method, which is going to be kind of difficult. And it's not very difficult, but it is a little bit more complex than the last thing. The first thing we'll want to do is say if the connecting pipe is null, just return. And this is just so that if we, for whatever reason, did not get a connection properly, we don't get any null errors. Maybe you would want to log a warning in here or something. That's up to you. Okay, and then the next thing we want to say is if the colliding player is not null, which means we have a player that is colliding with us right now, we're going to switch on this pipe's direction. And depending on which direction the pipe is, we'll check and see if the player is pressing the appropriate key to get into the pipe. And if he is, then we will just make him travel through the pipe, quote unquote. So let's say case up. If the player is on a pipe that is facing up, we'll say if the key listener dot is key pressed glif w key down, and we'll go ahead and import that from lwjgl, or inside these parentheses, we'll say key listener dot is key pressed glif w key s. So we're basically just going to support WASD and arrow keys, and then we'll say, and this is an entrance. So we'll say if they're pressing the appropriate key and this pipe is an entrance pipe, then we basically want to make sure that they travel. Let's import this as well, and that should be good. And I'll just move this down a little bit more so that we can sort of see this. We'll want to do something basically exactly the same for all the other things too. So let's just break here. Then we'll say case left. If we're going left, what do we want to do? Well, if they're pressing the right key, so key right, or if they are pressing the D key, so glif W, key D, we should do the same thing. Let's go ahead and import these. And now now IntelliJ has imported everything for me automatically. So then we'll say case right. Basically, we want to do the exact same thing, copy that, and we'll say case down, same thing. So if the pipe is facing the right, we want the key left, and we want key A. And if it's facing down, we want the key up, so up arrow key, or we want the key W. And that should cover all our bases. Now, how do we actually enter the pipe if the player is collided with it? Well, we can just set the player's position to this pipe plus the player's height, right? So we can literally just say colliding player dot set position, which we will add in a moment. And so we'll say set position to get player position, which is another function we'll create connecting pipe. So that should get the player's position and then set the position appropriately. And we'll also want to make sure to play the pipe sound. So we'll say asset pool dot get sound assets slash sounds slash pipe dot ogg dot play. And I just realized that we could actually simplify this quite a bit. So let's go ahead and simplify this because all the rest of my switch statements are exactly the same. So we'll say player entering is false. And the reason I'm doing this is because basically we're going to do this exact same code in each of these switch statements, which is kind of useless. So let's copy this, and then we'll just say player entering equals true. Then let's paste this below the switch statement, and we'll say if player entering, then we'll do that. And we can just go ahead and mark player entering as true in any of these cases, which should make sure that we enter this. So if the player is entering the pipe, we just set the position accordingly to whatever this pipe is. So we say set position to get player position, which we will create pretty much now. So let's go ahead and implement get player position. This will be a private vector 2f get player position. And this is going to take in a game object, which is another pipe. So we'll say pipe component equals pipe dot get component pipe dot class. This should get us the pipe component. And using that, we can figure out which direction the other pipe is and get the appropriate amount that we need to go based on that. So we'll just say switch pipe components direction. And we can say case up. So if we're facing up, then we'll return a new vector 2f pipe.transform.position.add 0, 0.5. So we're just going to add the pipe's height to Mario, and then we'll basically do the same thing for all the other cases. Left is going to be the same exact thing, except we want to do negative 0.5 and 0 because we know the pipe's heights and everything. And then case right, we want to do basically the same thing, except we'll add positive 0.5. And for case down, we will do the same thing, except we will add negative 0.5 to the y values. If all else fails, we'll just return an empty vector 2f, which should add nothing to the player's position, thus setting it basically the same place. This is basically just going to set it to the connecting pipe, which is the pipe we want to go to, and then it's going to add the correct offset depending on which direction the connecting pipe is facing, which should give us the correct thing. Now let's go ahead and implement set position very quickly inside the player controller. This is actually really simple because we just want to make sure that we set the position inside of here so that the physics engine gets updated properly. So we'll say set position. This takes in a vector 2f, a new position And this will just say this .gameObject.transform.position.set to the new position. And it will also say this .rb.set position to the new position. That way the physics engine gets updated appropriately. And this means we need to go into the rigid body as well and add it into here, which we can do pretty easily just by saying public void set position vector 2f new pose. And we'll say if raw body does not equal null, then raw body dot set transform new vec2 new pose dot x new pose dot y and 0 for the angle, which I guess we decided that this could just be the game objects transforms angle or rotation, which should be good as well because that should be 0 for the entirety of the game anyways. And with that done, you should see that we get this set as well. Now, this will all work good inside of the update method, but that's assuming one thing, which is we have this colliding player variable set, which it's not because we don't know when the player is colliding with the pipe. Well, how can we know when the player is colliding with the pipe? And that's pretty easy. We already know that we can just override our collision method. So we'll simply override our public void begin collision method, which takes in a game object, colliding object, a contact, and a contact normal. And this should be very familiar to you by now. I hope you guys can appreciate the importance of these collision methods that we set up in the previous episodes. So right here, we'll just say player controller equals colliding object dot get component player controller dot class. Okay, so we get a hold of the player controller. And if it's not null, meaning that the player has collided with this pipe, that's what this means. Then we'll switch on the direction. And we'll say if we're a pipe that's facing up, we'll check and see if the player is hitting us going down. So we'll just say if contact normal dot y is less than the entrance vector tolerance, meaning that the player's normal is pushing up compared to us, then we will just return. And that is because it's not actually meeting our tolerance yet. If it's greater than that, then that means we are actually having the player push down on us appropriately. And then we'll break. We'll say case, right, if the contact normal.x is less than the entrance, then we'll return. Otherwise, we will break. Then we'll say case down, almost the same thing. If contact normal.y is greater than negative entrance tolerance vector, we return. Otherwise, we break. And then we'll say case left if the contact normal.x is greater than negative entrance, then we'll return. Otherwise, we break. And this is sort of just a way to return early. It just makes the code a little bit cleaner in this specific instance, which is why I chose to do it this way. Then we'll just say colliding player equals the player controller, which means we now have a reference to the player controller if they have indeed collided with us. Now this is all good, but we want to make sure that we end the collision, because what if the player turns away from the pipe? Then we want to make sure to mark that as well. So let's go ahead and actually copy just these two lines, because we can override the end collision method, which we haven't actually done yet. So we'll do that, and then I'm going to go ahead and close off that function, and we'll call this end collision instead. Takes in the same parameters, but now it's telling us that the collision is ended. And we will just copy these two lines of code as well, and we'll say if the player controller has collided us, then colliding player equals null. So basically, this just means that if the player was colliding with us but is no longer colliding with us, then we just set it to null. So that should be pretty simple, and it should do everything we want it to do. Let's go ahead and see if this works the way we think it should. So I will go ahead and grab a couple of prefabs. I'll have an entrance pipe right here. And this is going to look weird for now until we can fix the spacing. And then I'll add an exit pipe up here. So I'll call this entrance pipe. We can go into the pipe component. We can see it's facing up. You could change the direction if you want, but it doesn't make much sense. And we should have a way to input the name, but we don't. And why is that? Well, that's because I believe we haven't implemented a text box for strings yet. Yeah, because we have this string and it's not marked as transient, so it should be exposed, but it's not. We can do that pretty simply just by going into component, and we will go up to where we have our ImGui function, right? And you'll see that we don't actually handle the case for a string here. So we can just add that below type is enum. We'll say else if type equals string.class. So this means we just have a string. We can say field.set this ImGui dot input text, and we'll say field.getName plus a colon. So this will basically just be the field's name and make it look a little bit nicer by using our extended function. And then we'll just say string value, and this should be a capital S, which should, if we look at this, this returns a string for us. So basically what ends up happening is we get the string that's currently there. Then if it changes, it returns a new one, and we just set the field automatically. So if we run this now, we should be able to click onto this pipe, and you can see that if we click on the pipe component, we get connecting pipe name here. It's squished a little bit. You can move that over if you like. We'll call this entrance 1, and we'll call, or actually I guess we should call that exit 1, right? And we'll go ahead and we'll rename this pipe to entrance 1, and then we'll go ahead and rename this pipe to exit 1 so that we have that name set properly. And we'll say this guy's connecting pipe. If we go back into the pipe component, we'll name his pipe to entrance 1. And just for fun, I'm going to set this as an entrance, and I'm also going to set this one as an entrance. So if we set both of those as entrances and then we hit play, I should be able to click down, and it's not working yet. So we have some bugs that we need to work out. And on second thought, that actually is working for me. What my guess is that we have the tolerance vector a little bit too high, and it doesn't always register that Mario is actually hitting the pipe. So you could do some more fine tuning to get an entrance tolerance vector that works a little bit better. But if we run into the pipe from the side, he doesn't go through it. If we run into the pipe from this side, he doesn't go through it. Only if we hit it from the top, and apparently we get an appropriate entrance vector. So what we could also do is if we check the pipe and we uncheck is entrance, we should no longer be able to go into it. So no matter how hard you try, Mario will no longer go into the pipe. We could test this with all the pipe directions, but I'll leave that up to you guys because this should be working properly for all of them. Like I said, the one bug we have is the pipe entrance does not always fit perfectly. Now, one thing I am going to say is let's go into key controls because this has been bothering me for a while. We need a way to easily edit our game world, which we do not have right now. So if we go into key controls, we can add some more key bindings. Let's say if keyListener.key is key pressed, GLFW key page down, and debounce is less than 0. We will be adding a debounce, and this is just that you can hold down keys and move items for several frames. We're going to bind the page down and page up keys to change the Z index. So we'll just say debounce equals debounce time. And let's go ahead and add those variables very quickly. So if we just scroll up to the top, we can say private float debounce time equals 0.2f. Private float debounce equals 0. This means that if you press down a key every 0.2 seconds, it will repeat that key press, which is what I thought was a good value. If you don't think that's good, that's fine. Change it. Inside here, we'll simply say debounce minus equals dt so that we can keep track of that time. So back to the page down. So if they press page down, we'll say for GameObjectGo in all the active game objects, we'll simply say go.transform.zindex minus minus. And we'll want to do basically the same exact thing, except if they're pressing the page up key, we want to change their z-index to 1 higher. So we'll plus that z-index. Otherwise, we want to add in a couple more key bindings. If they press the up key, so not the page up key, but just the up arrow key, then we're going to go ahead and instead of moving the z-index, we'll say go.transform.position.y plus equals settings.gridHeight times multiplier. And this multiplier will basically just be like shift. If you're holding shift, it will change it so that you're moving it in smaller increments, which is how we can reposition those pipes. Good. And we'll basically do the same thing, except for the left arrow key. We will say .x minus equals this. And for the right arrow key, we will say .x plus equals this. And lastly, we will say for the down arrow key, dot y minus equals this. Now that multiplier value is pretty simple as well. We can just go up to the top and we'll say float multiplier equals key listener dot is key pressed glfw key left shift. So if the player is pressing the left shift key, we'll move at 0.1 increments at a time. Otherwise, we'll move 1.0. So this means we'll move 1/10 of a grid space if they're holding shift and the full grid space if they are not. So if we run this again, we should be able to move these pipes into a better position. Just click it, hold shift, and then press the arrow keys to move it into a better position. And you'll see that you can actually move the pipes into a good position. And I'll move it directly into a grid space just so that we can see that. This is also good too, because now you can select multiple blocks and just move them with the arrow keys. Move them a few spaces if you want, just to give your world some variance. So if we go ahead and run this again, you can see that we've sort of got a working game. And I still have this pipe off, so that's why we can't go through it. So I'm just going to remark that. Also too, if we add in a couple decoration blocks, say we wanted a bush here, which you could also create as a prefab to make this easier on yourself. You could have like decoration prefabs and all that stuff if you wanted to. I'll go ahead and collect all those and then move them down by pressing the page down key. Now they're behind Mario. And if we were to select all of them again and hit page up twice, this will make sure that they are in front of Mario. I'll grab that one behind him, press page up twice. Now it's in front of Mario. So this is really turning into a full-fledged level editor that you can use with your game engine to create some pretty complex levels. And you can, of course, add more key bindings and add any other components you want. So that's going to be it for this tutorial. In the next tutorial, we're going to work on the camera movement. So we'll add it so that when Mario moves a certain amount to the right, the camera moves to the right and then it stops moving. And we will also change the background color to the real Mario sky blue. I hope you guys enjoyed this. If you did, please hit like and subscribe and stay tuned for the next episode. Thanks.